Left. All right. I have one. It's just dead also. Come to find, you got to plug those in. I just can't crank it. I want one that you crank. All right, guys. So exclusive means somehow it excludes. Mutually exclusive means you don't want me and I don't want you neither. So mutually exclusive would be something like, let me say, two events that are not mutually exclusive are like woman and Republican. Why are those not mutually exclusive? Are there any in one that are also in the other group? Yes, there are women Republicans. I love it. Does that make sense? Okay, I'm not talking ideologically. I'm just saying, does it make sense? The idea, right? So mutually exclusive would be, I used to say cats and dogs, and then there was a cartoon where there was both, and I didn't want to think about the biology of it, but so now I say something like chair and ice cream. Are there any ice creams that are also chairs? And you're like, well, if you freeze it enough, shit. But, so that's what mutually exclusive means. There aren't anything in one that's also in the other. They mutually exclude each other. So visually it would be like this. There's no overlap. Men and seaweed. Right? That's a really weird insult to say, man, you like seaweed. No. I don't know what that means. Men and seaweed. There's no seaweed that's also a man. Alright, wait to see if somebody said, well, actually, I read this thing show. Do you understand? So what does this mean about the probability of A and B then?
0.
It'd have to be 0. So jacks and 8s. Are they mutually exclusive? Yes, because there are none that's in both. That's what you think to yourself. Can I think of? How about jacks and diamonds? Are they mutually exclusive? No, because there is something. There's at least one thing that's in both groups. The jack and diamonds. It's amazing. Do you guys get what I'm saying? Doctors and people that eat ramen noodles for lunch. Of course, I'm sure there's a doctor that eats ramen noodles for lunch. I'm with you. You guys. So if you can imagine that there's something that's in both groups, then they are not mutually exclusive. I like it. All right. This next idea is a little bit weird. And you're all like, what else is new, Jeff? Independent. So I used this word earlier, but what does this mean mathematically? It means this. This is exactly what you would hope it would mean. Please let this make sense. If the probability of A given B is the same thing as the probability of A. So what does that mean? That means that B happened and did A care? The probability of A given B is the same as the probability A was before. So B happened, right? Given that B happened, did A give a shit? No. 0 shits were given. So it makes sense to call them independent. Do you guys understand? No. I'm not sure how else to say that. So if... I don't know how else to say it. If somebody in Wyoming right now dropped a phone book on their foot, would you care? No. Independent. That would be a very strange, specific. There's a disturbance in the force. It's as if one voice cried out in small. So, I mean, I really want this to make sense. B happens, but did it change the probability of A happening? No. That's what this says. If this is the same as that. If B happens and A doesn't change, then we call them independent. This is actually sort of a definition. If B happens and A doesn't change, then they would be independent. So for example, what's probably of a jack out of the deck of cards? 4 to 52, which reduces to what? I'll just do it. 1 out of 13. And real quick, notice how it's 4 jacks out of 50 cards, but for every suit there's 1 jack. So when it reduces, very often probability means something. 1 jack for every 13 cards. 1 jack in every suit. Ooh, okay. What's the probability of Jack given that it's a club? What goes on the bottom? No, it's given that it's a club. 13. Out of those, how many are Jacks? 1. Did this probability change? So these are independent events. If I tell you the card is a club, did I just change the probability it's a Jack? No, I didn't. So those are examples. Now watch. What about face card in Jack? If I tell you the card's a face card, should that change the probability it's a Jack? What do you think? Yeah. It should make it go up, shouldn't it? If I tell you it's got a face on it, there's so few cards with faces and Jack's one of them, it's going to make that probability go up. They're going to be dependent. So the probability of Jack is this. What's the probability of Jack given a face card? Well, how many face cards are there? Jack, Queen, King, times 4 is 12. So out of 12, to understand you must listen. Jack, Queen, King, for every suit, and there's 4 suits. So there's 12 cards that have face